I'm Anil Kumar, and in this video we are going to learn different techniques of finding solutions to discrete sequences. Now these sequences which we'll be discussing are neither arithmetic nor geometric, and therefore they're kind of tricky. Now you may really have to apply many different techniques to get the real solution. So let us consider the very first question here, which is write a general term for the sequence 9, 9, 9, 9, 9, 9, and so on. Now, how will you get the general term for such a sequence? It is very easy to write next three terms, right? Just keep on adding nines, one after the other. But how do you write a general term for a sequence like that? And that is the question which we are going to discuss now. So let's find a strategy. So we have these numbers. One is 9. And then we have two nines put together. Then we have 9, 9, 9, and then 9, 9, 9, 9, and so on. Sometimes it's a good idea to write them big and bold so that you can concentrate and think about those terms. How do we get 999, 9099, and such numbers? Well, one way is that if I take away 1 from 10, I get 9, and if I take away 1 from 100, I get 99, and if I take away 1 from 1000, I get 999. Similarly, if I follow this pattern, I do get these terms. Do you get the idea? Now, when we say general term, that means we have to relate these numbers with term number. So what is the term number? Let's write down the term numbers. So first term is 1, second is 2, third one is third term, then we have fourth term, and so on. Now general term will mean T of n, right? So these are the numbers, term numbers. General term means T of n. That is how we develop our formula. Nth term will be nth term. If T1, so T1 is going to be the first term. And from this relation we just developed, we could write T1 as, in relation to 1, what is 10? 10 to the power of 1 is 10, right? Minus 1. Do you see? For 2, we could write T2 as equal to 10 to the power of 2 minus 1. 10 to the power of 2 is 100. T3, third term is 10 to the power of 3 minus 1. Fourth term will be 10 to the power of 4, and then take away 1. So the general term you could write Tn as 10 to the power of n minus 1. Do you get the idea? So 10 to the power of n minus 1 becomes the general term. So we'll say, well, the general term for this type of a sequence is 10 to the power of n minus 1, right? I hope you understand and appreciate how we got this particular formula, right? Now, let us apply this formula to find general term for a similar sequence. So that is a test question for you. Test question for you is, let me write down the sequence as 1, 1, 1. Like this. Now, can you tell me the general formula for this sequence? Well, let me add one more question to this. How about if I change the sequence to 5s? Or 7s for that matter. I mean 3 5s, correct? 4 5s, and so on. Can you write down now the general term for these sequences? That is an exercise for you. Think about it, pause the video, and then check with my solution. Let me give you the answer here itself. We know that 10 to the power of n minus 1 is going to generate 9s, right? We need 1s. What should we do? We can divide this by 9. Do you see that? So we can write Tn as this for the first one. Now you got it. For the last one, or the second question, you can write Tn as what? You can write Tn as, once you have to get 5 times. You could do it 5 over 9 times 10 to the power of n minus 1. That gives you the answer for the second question. Now this is a very powerful technique and will help you to solve many questions in this particular unit. I hope that helps. I'm Anil Kumar. Subscribe to my videos and learn a lot. Thank you and all the best.